Hello students, welcome to Satya classes. Myself Raj Pandey and I am here to teach you physics. In this presentation, you will learn about some basic concepts that are really useful and help you to learn and understand physics. So let's begin with these basic concepts. The first one is conversion of units. This one is also an use of dimension you have studied earlier. Order of magnitude and how it is useful for us. The structure of this world, really most interesting topic. And before we proceed, let us revise what we have learned in previous. So we have learned there uses of dimensional analysis. In this, homogeneity of dimensions in an equations means how to check that equation is correct dimensionally or not. Deducing relation among physical quantities when the quantities are dependent as a product on a single quantity. Understanding? And we have also solved one question based on these two methods. Understand? So let's begin from uses of dimensional analysis, that is conversion of units. So now when we talk about conversion, this means what? We are working with a set of quantities, means we have not a single quantity, not a single basic fundamental quantity. Now we have different quantities. Like a set of quantity means more than one quantity, more than one fundamental quantity. Like you have length and time, mass and many more, means the remaining four. Yes, exactly. So in this method we have to find conversion factor. When we convert one unit to another system of unit, then we have to find the value of conversion factor. We will see soon how to do it. Since we know that we have the following system of units like CGS, MKS or SI, MKS also known as SI, and FPS. Do we need to explore the name of these units? I think you know about it. So we can write any quantity with different system of units. There only be difference of conversion factor. So let us see what is this conversion factor by following example. The example is how many CGS pressure is equal to 1 Pascal. This one is the question. So let us understand what is it. So before we proceed, let us check that what is pressure. Pressure is force upon area. So now you are able to calculate the dimensional formula. Yes, of course, I think you can. So I wrote here the dimensional formula of the pressure. The first step is to write the dimensional formula. When you are going to convert the unit, you are converting the unit, only unit, not the quantity. Means you are not converting the pressure will remain same. You are converting the unit of pressure that was in CGS and you are converting it into Pascal. Understand? So the dimensional formula of pressure is ml minus 1 T minus 2. You can calculate by using the basic formula, that is pressure is equal to force upon area. Should I need to write? Okay, let me show you. Pressure equal to force upon area. By using this formula, you can calculate the dimension formula of pressure. Okay, so this is come out to be ml minus 1 T minus 2. Now, Pascal is a SI quantity. So you can write it as, in the place of m, you will use kg, means 1 kg. In place of L, we'll use length which is in meter, and in place of time you will use second. So this is the expressed unit in terms of the fundamental units, understand, in terms of fundamental quantities. Okay, and for CGS means centimeter, gram, second. So here you can see we use centimeter and gram and second. Now what is this power indicate? This power indicate the formula, means I mean to say you can convert any unit in any system, but their dimensional formula will remain same, it will not change. So you can see here L has power -1, so m 1 meter is also length, so m -1, s -2, here also s -2, length -1. These are the power I took from here because it will not change. Now let us divide both the equations. On dividing, 1 Pascal upon 1 CGS pressure, we get 1 kg upon 1 gram. Okay, we are dividing kg with means mass with mass, and length with length, and time with time. So kg upon kg, meter upon meter, and second upon second. Kg upon kg, meter upon meter, second upon second. But look here, you can see this is gram and this is centimeter, so we have to convert these unit, or either we can convert the kg and meter. So in this time I have converted 1 kg is equal to 10 to the power 3 gram, and gram cancels each other, so it becomes 10 to the power 3. Now what about this? Yes, 1 meter is equal to 10 to the power 2 centimeter, means 100 centimeter, or you can write it as 10 to the power 2. So this becomes, on calculating this, you will get 10. You can pause the video and use your note copy. These are basic calculation, just depend based on base and exponent. So now when 1 Pascal is equal to, now this quantity 1 Pascal upon 1 CGS pressure is equal to 10. So 1 Pascal is equal to 10 CGS pressure. Now you got the answer. 1 Pascal is equal to 10 multiplied by CGS pressure. So what is the factor 10? This factor is known as conversion factor, and we did all the things just to calculate this conversion factor, so that we can go from one system of unit to another system of unit. Understand? Okay, so let's move to homework problem. Okay, after studying that concept, we can generate a formula. Yes, of course we can, but we do not generate any formula because we have a lot of formulas, and generating formula and dividing formula is not I don't think that it is a very much a good thing, because to create a formula is important, but the most important thing is how to create. The way of creating the formula is more important. So now you have the base, the following base, so need not to create a formula. Okay, I suggest you not to create any formula, just look at the basic concepts and solve the question. So here I have given an example. This one is your homework problem. Okay, this one is your homework problem. So the problem is, the SI and CGS unit of energy are joule and erg respectively, means you can express energy in joule and also in erg, but when you represent it in joule, you are representing it in SI unit, and when you represent the energy in erg, you are representing in CGS system of unit. So the question is, how many erg are equal to 1 joule? The question is, how many erg are equal to 1 joule? For to be solved this question, take pen and paper. I'm hinting you how to solve this question. Okay, so look here clearly. Find dimensional formula of energy. The first step I proceed in your previous example. first of all you will calculate the dimensional formula, then define them by fundamental unit for SI and CGS system. Okay, see, I wrote here, this one is SI and this one is CGS. So you need to do same for these two units and then divide the units. You will have the conversion factor, and as you know, conversion factor is important factor, so you can relate the both the quantity, the erg to joule. Okay, and after solving this, post your answer in the comment section. Understand? Okay, so we have done conversion of units, so let us move to order of magnitude. Now, to understand order of magnitude, I have some awesome example for you. So the first one is size of mountain and the size of the tip of the pin. This is the mountain, huge, bigger, means we can use any word, bigger to biggest for this mountain, and smallest to smallest for the tip. But these are not the significant way to say that this is much bigger, because bigger and smaller are the comparative words. These do not tell the exact meaning, but in physics we have to calculate the exact meaning, at least some feeling. So when we talk about size, this means what? It may be length, area and volume. Means only a single fundamental quantity, that is length, is playing an important role. While calculating length is there. While calculating area, again length is there. While calculating volume, again length is there. If we'll talk about the dimensional formula of length, then it is L. For area it is L square, and for volume it is L cube. Yes, so we have explored first fundamental quantity. Now move to second one. Okay, so do you know how much is the mass of galaxy? Oh, okay, what about hydrogen mass of hydrogen? So this one is also mass means what? In dimensional formula, capital M, and will represent soon that how they are bigger and how they are smaller in comparative way, in a number, in a numeric form, so that we can easily feel about the size and mass. And the tertiary thing is age of this universe. So saying it is very old is not the significant way. Okay, so we have to tell the number. I am again saying the number, saying again and again. It means that the number is important. The math is important to carry physics. The time taken by an electron to complete a circle around nucleus, means this is the thing that we cannot see. We cannot see even an electron, and we are talking about the time. So this one is very small. Saying this again will not significant. So let us check how to do it. Okay, to have the feel of these largeness or smallness of such quantity, so we use power of 10 method. What is this method? Let us see. So for this method, we express any quantity in terms of a into 10 to the power b, where a has the limitation that it will greater than 1 and lesser than 10. It will be greater than 1 and equal to 1. It may be equal to 1, but it may not be equal to 10. See the brackets I used here. One is the closed bracket and one is open bracket. So for example, we want to express the diameter of sun. So big. Understand? No, this time I will not say so big. I will say a number 1.39 into 10 to the power 9. We was not interested in units, so I didn't wrote the unit here. This is in meter. Okay, So the 10 to the power 9 number, 10 to the power 9. Now we have the field that 10 to the power 9 may how much. We can use the zeros and we can calculate it so that we can have the field. But what about 10 to the power minus 19? This one also you can calculate. Okay, so the difference in them is this one is positive, this one is negative, but these number 10 to the power 9 and 10 to the power minus 19 are known as the order of magnitude. This one is the known as order of magnitude. Now I took a very important problem from HC Verma just to understand this order of magnitude. So we have to estimate the number of person sit in a circular field. Okay, so we can see this is the circle and inside this so lot of person are sitting because its radius is 800 meter. So for finding how many person are sitting inside this circle, we have to divide the total area by the area occupied by the single person. Understand? So the area occupied by the single person is 0.25 meter square. That you can write 2.5 into 10 to the power minus 1, means in that way. Okay, and on calculating area using the formula A equal to pi r square, use copy and pen for calculating this. Now you are not layman, you can calculate at least area, you can calculate. So calculate the area and ignore the number that is before 10 to the power 6. Okay, means ignore the value of A, because we are now interested only order of magnitude. Okay, so dividing both the quantities, you will have 10 to the power 7. So the person can sit there in order of 10 to the power 7. Now it may be multiplied by 2, 3. Now you have at least the feel of this thing. Have you getting what I'm telling? 10 to the power 7 is just a biggest number, because now we know that 10 to the power 7 is biggest. But why we are calling it biggest? If there will 10 to the power 12, what we call that number? That number will also call as biggest. No, that will be not the good, because when we say biggest, it is comparative word. It is comparative word, means we are comparing this word to some other number. But in physics the numbers are important, so we'll call it as 10 to the power 7. Understand? Are you clear? Okay. Now the structure of word. Now we have started talking about the structure of word. So there is a lot of curiosity that how this word has made, who is the responsible for making this word, and there are millions of things are generating day by day. So who is responsible for making those things? Okay, for this we have 3 particles. The word is made up of 3 types of ultimate particle. That particle are the electron, proton and neutron. These are the fundamental particle, and for every biggest to bigger thing, okay, these particles are important. These particles are playing the role to generate them. The molecule are made from atom. You know well, atom have their heart, a nucleus, means inside the atom there is a heart, and that heart contain proton and neutron. So what about electron? Electron move around this nucleus in a special arrangement, and the number of these fundamental particles like electron, proton, neutron, these things decide the property and behavior of material. Understand, these number define the property and behavior of material. So what next? Classical physics. Now listen me carefully. What is the classical physics? The laws that we deduce are for these macroscopic object, and every time they will not be always applicable to the fundamental particles, nucleus, and atoms, molecules. They may not be applicable because these particles are much smaller in size. They are much smaller in size. If I compare this particle from the dust particle, a single dust particle that contain at least 10 to the power 18 atoms. Okay, so that dust particle can be considered in classical physics, but these fundamental particle cannot. So we'll study about this physics, and this physics is completely related to the laws of heavy bodies that have millions and billions of atoms and molecules. So now, are you clear with this? Okay, so we'll close this presentation right now, and see you in the next presentation. Now you are master in unit. I have told everything, and just revise them again and again, and you will have the knowledge of this unit, and even you can tell anyone you like to do. Thank you.